Hello, I just want to make an update on what I'm working on right now. So I'm working on my statistical package, Statista, which is about extreme value analysis, Gumbel, and generalized extreme value distributions. So the work is all in my GitHub organization. So it's called Sterobium of Alex. So that's where what you will see if you open it in GitHub and you go down. That's the structure of all what I'm working on. So that's what I'm going to talk about today, Statista, and it's about distributions and the parameter estimations for these distributions. So it has Gumbel and generalized extreme value. It has also exponential distribution and normal distributions and a couple of other modules to help this main module. So if you go down, you will find it here, Statista, or you will type it here and you will find the package, so Statista. And the documentation that I'm currently working on is in a pull request, and all the documentation is posted on read the docs, and for it is one of the checks of each pull request. So it's here, you open it like this, and here you will find all the package modules on the left, and the methods you will find it on the right. So they are all also on the top here. So here in the installation, that's how you install it. The package exists in on Conda and on pip as well. So yeah, if you go on the very first page, the installation, yes. So if you write pip install or Conda install Statista, that's how you install it and you get going. So pip and Conda here as well. So yeah, the main package, the main module is distributions, which has yeah, here are on the right. So Gumbel, TV, exponential, and normal. And if you see, the name of the methods are exactly the same in each one of those distributions. So and it has encompassing general class called distributions, and from this distributions class you can call all the other methods below it, which are these other distributions. So yeah, to initialize any of these distribution classes, you need the data or the parameters. The parameters argument changes. Some distributions need 2 parameter, location and scale. Some distributions like GEV need 3 parameters, location, scale, and shape. And you have, for example, the PDF method where yeah, you plot the probability density function. And in the example you see here how you use this method. There is also the cumulative distribution function method, CDF. And yeah, here's how you use it. And also confidence interval fit distribution. So you have your data and you want to get the parameters. And this is one of the main reasons I built this package, is to use this L-moment method to estimate distribution parameters, which doesn't exist in SciPy. SciPy has a maximum likelihood estimation and other couple of methods that didn't work for my charge time series. So that's why here's one of the main advantage of this package is that I wrote this L-moment parameter estimation for the GEV and Gumbel distribution. So yeah, you can use it simply just by reading your data, instantiating the class, and use fit with defining that the estimation method is L-moment. And you will also get metrics of how successful the parameter estimation is. So all of these methods are exactly the same for all the other distributions, and all of them has also examples. So another module is the sensitivity analysis, which has two main methods, one at a time This is a sensitivity analysis method called one at a time, which fix all the parameters of your function, and it change only one parameter by steps, and it plot these changes with a figure called Sobel. So there is here an example of measuring the sensitivity analysis of distributed hydrological models. The model based on it's an HBV model based on the parameter of the HBV, and the Sobel, this Sobel plot type. That's how it looks. So these are all the parameters, and these are the values that the package evaluates how the model works at, when you change one parameter and fix all the other parameters. So there's also a metrics module which has statistical descriptors, what we call in hydrology metrics, efficiency metrics. So this is Kling-Gupta, mean absolute error, Nash-Sutcliffe, mean bias error. Yeah. And there is another module for plotting all of this statistical analysis. So yeah, that's all. So again, it is in GitHub in my organization. So go and check it. Bye.